have slides. So my presentation, yeah, is unconventional. So I'm gonna be talking about some statistics and data visualization. So feel free to fall asleep right now. That's your chance. Yeah, but right before that, I'd like to ask you just one question. So how many people here were surprised when Donald Trump was elected as a president of the United States? So yeah, I suppose it was like a great surprise for all of us, right? And of course, media was very reporting like chances, probabilities of Donald Trump and Hillary Clinton winning presidential election. Of course, like they were relying on polling data, and maybe polling data wasn't so good. So yeah, maybe as a part of a problem, as a part of like explanation why we were surprised was the bad data they were using for prediction models. But also the part of the problem is they probably were failing to explain what is probability or what are chances. So they were failing to explain this all underlying stats in their statistical in their prediction models. So what I'm thinking about, we are talking a lot about tools for storytelling, but I think we have more problems with understanding what we are doing with storytelling, especially with data storytelling. And we should probably think about something like correctly reporting data. And like we deal a lot with the data with uncertainty attached. I mean, probability of you surviving my talk to the end is like pretty low, yeah. So, but I'm acting with this uncertainty attached, and like we have this uncertainty every day, like on everyday actions, like when we going, when we computing, when we like expecting something. And also we have like a lot of data to report with this uncertainty attached, like everything related to polls, everything related to household service, everything related to some kind of prediction. So we need to report it correctly, not just stating one number, but telling broader, richer story. And if we fail to report this uncertainty in data, we fail to tell the whole story. So, for instance, I love this brilliant project by New York Times because they not only report in data, it's like jobs report, which is really important stuff for states. They not only reporting data in this project, but they also educating their readers because they showing, okay, we have this jobs report, but it's coming with uncertainty attached. And what you think is a steady situation can be something really different. And if you imagine something like this, and then attaching this uncertainty coming with data, you can like see totally another picture. And people actually relying on these job reports. People are basing their decisions on these reports. And when you're not understanding all these uncertainties that's coming with data, you probably will make some bad decisions. So, where just what is the problem? Why media failing to report uncertainty? So, I think the first thing is they just don't understand what is uncertainty in data. And it happens a lot. I mean, I used to work with a journalist who was struggling with the percentages. So I cannot expect from them to report something like uncertainty. But even if they understand what's going on, they fail to report it because they're afraid that their readers won't understand it, right? Or maybe they don't want to report something like, maybe it's gonna happen, maybe not. We don't know, we really don't know, right? That's something that I wouldn't personally report as a journalist who used to like sitting on a news feed and publish news because it's like not interesting headline. Or even if they like accepting, they, okay, we can educate our readers, maybe they don't know how to communicate it properly. So here are few strategies. So first we have to understand what is, what kind of uncertainty we have in data, and this is like statistic 101 for journalists. So usually we're working with polls or household surveys, and usually we have something like margin of error, confidence level, and probability distribution. It's like that's kind of data that we can use to report uncertainty. So margin of error is really simple. Imagine like I want to make a quick survey with like tech camp participants or Rockit participants, trying to understand how many people think that Rockit is cool and how many people think that Rockit is super cool, right? So I cannot talk to all of you. So I have to select. I have to like base my survey on some sample. So I have to select some people to talk to. And of course, like my sample should be based maybe on a structure, on general structure of the whole Rockit participants, right? So it should be corresponding. And when I'm basing my survey on sample, I have this margin of error. I mean, I can reduce it by increasing sample size. And when I'm talking just to a lot of people, I'm reducing margin of error. It's like difference between data in my sample and general population. So it's really easy stuff to report, right? So usually we're reporting something like, okay, so 55% of Rockit participants think that it is super cool, right? But this data can come with like margin of error of 5 percentage points. That means that like when we're talking about the whole Rockit participants, our data can be like 55 or 60 or 50, right? So real number falls in this range. So it's really easy to understand, I think. And usually we have this kind of metadata when we receiving polls from social company, and we can report it, but usually we don't. Like it's not something common in media, even if mainstream Western media, but we should totally do that. Or we have something like confidence level. That's really easy to understand because it's connected to the previous. Imagine that, like, okay, I want to do the same survey with Rockit participants. And imagine, like, if I'm doing it survey like 100 times, first I will be exhausted, of course, but then I will have something like confidence level with 95. That means like 95 times of these 100 surveys, I will get results in certain confidence level. So it's like 50 plus minus 5 percentage points. So that's really easy stuff to understand when you just think about for a couple of minutes. And this is not. But usually we're not dealing with it because we're not receiving this kind of data within polls because like it's coming with, it's kind of metadata companies not sharing with us. But it's crucial to understand. So like we have probability of different outcomes, like service results. And like for every possible outcome, we have a probability like for this result to happen. So let's try to understand how to visualize it. We can use at least 3 different techniques. So first one is showing error bars. Second one is plotting probability distributions. And the third one is running simulations. And actually, simulations is what polling results are based on. And the problem is we only see results of simulation, but we don't usually see the process, and that's why we don't understand it. So error bars is actually pretty easy. So these blue lines we have is the mean. It's like this 55% of Rockit participants who think that Rockit is super cool. But we have this margin of error attached, right? And we have these smaller lines showing it. So this is pretty easy. So we're showing that, yeah, we have mean value, but we have margin of error, and we're showing it. And like this kind of thing, consider it pretty ineffective, because when we show in error bars, we implying that our readers understand they understand the concept, but they usually not. So it's better to show something like this. Instead of showing just static error bars, we're showing dynamically where our results can fall in. So they get in the process, not the static result. And that can be interesting and educating in a way. Or we can show probability distribution. It's like more richer story, because like we have all possible outcomes here, and we color coding probability of every possible result. So if you have darker color, that it's like more probable. And it's super cool because it's showing you the richer stories than you have before. So your readers actually getting more information for decision making. But the most interesting thing I think right now we can do is to show our readers the process of getting results, so they could really understand what's going on. And the most interesting project in this field for now is Project Rock and Poll by Belgian journalist Martin Lambrechts, who actually visualized the whole polling process. So this is a cool interactive scrollytelling story which shows you how polling works, so how sampling works. And I think that in this election interactives we had from New York Times, from 538, they could done probably something really similar, because they were running a lot of simulations to get predictions of Donald Trump and Hillary Clinton being elected. But they only reported the results of their simulations, and they never showed really simulations. And if they did, maybe we weren't so surprised when Donald Trump was elected as a president. So I'm not expecting that, like after my talk, you will go to your newsrooms and you will do cool interactive simulations. But what I'd like you to do is just to think how you report in numbers, how you creating stories with numbers. And like from my perspective, this kind of not technological question, it's like question of ethics of reporting. And of course, it requires some technical knowledge and skills, but this is really crucial for data-driven storytelling and for reporting in general. So next time you have like editorial meeting, just stand straight, establish eye contact with your editor-in-chief and say something like, let's think about how we're reporting uncertainty in data, all cool kids doing it right now. Thank you, and this is thank you with uncertainty attached to it. Yeah.
Slide share.